Application of fractions still continue, this time within capacity. Example 1, we shall be dealing much in taps. How many minutes does tap A and tap B combine together to put like that? So tap D can fill the tank in 6 minutes. You note we have tap D filling a particular tank in 6 minutes. And tap E can fill the same tank, of the same size and capacity in 3 minutes. I have a feeling that tap E is faster than tap D because it takes extra time to fill the tank. Now, here comes the question. How long will both taps take to fill the tanker if they are opened at the same time? I want to imagine I have a tanker. I'm sketching something small here to represent a tanker. I have a tanker. It can be of that cylindrical nature. It has maybe the hole. That is the tanker. We have 2 taps. I have a tap. This is a tap, which I can call D, and I have a tap, which will also put water in this tanker, and this one is called tap E. When tap D is opened alone, this tanker will take 6 minutes to get full. And when you don't open tap D and you open tap E alone, that tap will take 3 minutes to fill this particular tanker. So if tap D takes 6 minutes alone, then tap E takes 3 minutes when it is alone to fill that particular tank. Now here comes a time when both of them are opened at the same time. This one is putting in water and the other one is putting in water at the same time. In my own thinking and in the logic of this question, you can see that it will not take 6 minutes, neither will it take 3 minutes. Because the taps are now opened at the same time, this tanker will get full in lesser time than any of these two. So how do we approach this question? We shall say tap A, we shall find out the minutes tap D will take. Tap D, the fraction it will put in our tanker in 1 minute. Tap D in 1 minute. Tap D in 1 minute. It will fill in a fraction which is 1 out of 6. 1 out of 6 each minute. At the end of the day, you will see that by the 60 minutes it will be full. Then tap E in 1 minute. In 1 minute, it will take a third. It will put in a third of the tank because it takes 3 minutes. Our fractions are generated from the number of minutes each of them take to fill the tanker. So we shall need to find out both taps when opened, both taps in 1 minute. In 1 minute. What will both taps put in 1 minute? It will put in a fraction which is a 6 for the first tap added to a third of the second tap. So we can add to find out the fraction that will be put in by both taps in 1 minute. So here it will call for the LCM. The LCM of 3 and this of 6 and 3 is 6. So we shall have our 6 as the LCM. Then we can add this, a 6 times 6 is added to a third times the LCM. We reduce by 6 once, by 6 once, by 3 once, by 3, 2. 1 times 1 is 1 plus 1 times 2 is 2 out of 6. This will give us 3 out of 6. When we reduce 3 out of 6 to simplify this fraction by 3 once, by 3, we shall have 2. We shall have this tank half full when both taps are opened in 1 minute. So in 1 minute, when the two taps are opened our tanker will be halfway full. Halfway full. Now what is the question like? How long? How long refers to time. How long will both taps take to fill the tanker if they are opened at the same time? Now we are answering how long. We all know that since we are dealing with fractions, this tanker, when both taps are open, it will be half full. So it is this one whole tanker represented by a whole, the full tanker, divided by the fraction put in by the two taps when open. This one whole, when we are dividing fraction, there is a way we change the sign to a multiplication, and the second fraction becomes a reciprocal, and this will give us 1 times 2, which will give us 2 out of 1, and 2 out of 1 will mean 2. So it will take a 2 minutes to get full when both taps are opened at the same time. Excuse me. Similarly, in our example 2, you can look at tap A. Tap A fills the tanker in 8 minutes. So I can write here. I will not draw. Tap A takes 8 minutes. Tap A, 8 minutes. 8 minutes. Tap B fills the same tanker of the same capacity in 6 minutes, which means I can write tap B takes 6 minutes. 6 minutes to fill the same tanker. And then there is another tap. Tap C will take 4 minutes to fill that same tank. So these taps are many now. Tap C, for it takes 4 minutes. By logic, you can know that tap C is faster flowing than the rest of the two. It is faster flowing. Now the question comes, how long will all the 3 taps take to fill the tanker when opened at the same time? Now all the taps are putting in water in the same tanker. So when I look at 4 by tap C, 6 and 8, I will know that if 4 minutes are taken by a tap C only to fill that tanker, then my answer must be less than 8 of these minutes, because all the taps will be opened at the same time. What am I going to do here? I'm going to find the fraction for each tap in 1 minute. Tap A in 1 minute. Tap A in 1 minute will fill in 1 out of 8, depending on the time it takes. Then tap B in 1 minute will have put in a 6C when it is alone, right? Then tap C in 1 minute, it will have put in a quarter of the tanker. Each of these independently. Now we are combining all of them, and we want to find out how long will they take, which fraction will they put in when they are all opened at the same time. This is what we are going to do. We are adding all the fractions for the different taps. All taps in 1 minute. All taps in 1 minute. All taps in 1 minute, which fraction will they put? They will put 1 out of 8 plus 1 out of 6 plus a quarter. We are adding all the fractions to get what will be in the tank in 1 minute. When you look at all these ones, the LCM for these ones is 24. We are teaching candidates. You must be very fast as we are. And you must have already noticed that the LCM of all those 3, 8, 6, and 4 is a 24. I straight away come back here in 1 minute. My LCM is 24. Then I have the first fraction as 1 out of 8 multiplied by 24, added to 1 out of 6 multiplied by 24, added to 1 out of 4 multiplied by 24. I want to simplify very fast by 8 once, by 8 3, 6 once, 6 into 24 4, 4 once, 4 into 24 6 times. So 1 times 3 will be a 3, added to 1 times 4, which is a 4, 1 times 6, which is a 6, out of the whole thing, which is 24, the LCM. I'm seeing 6 added to 4, giving me 10, plus 3, which will be 13, out of 24. This is the fraction. This is the fraction put in by all the 3 taps in 1 minute. So we want to know if this is our whole number 1 representing a full tanker. How many of these are there? So we divide it because each of these is representing a minute. A fraction put in a minute. So the whole tanker divided by 13 out of 24 will give me 1 whole number multiplied. The sign changes to multiplication when we are dividing fractions. The following fraction becomes a reciprocal. So I'll be having 1 by 24, which is 24, divided by 13. Then I can now find out the actual time. 13 will go on 24 how many times? Once. And here it will go there only once. That is 1 whole number. What is the remainder? The remainder will be 24 take away 13, which is 11. 11 out of 13 as our time, minutes. Thank you. Follow through the examples and do the activity on page 30 and 31. You can also make a practice if you have activity books for perfection. Thank you.